In this tutorial, I will go over using a Python Pandas package to analyze the Johns Hopkins Covid-19 data using the Google Colab. So first, we import Pandas. By convention, we call it PD. We also import the NumPy and plot. And to install the data set from the Johns Hopkins GitHub site, and we run the exclamation sign, which is the run the system command, and then git clone, and that's the link of the Johns Hopkins data set from the GitHub. So if you want to get that link, you can click this green code, and there you can see the link to clone it. And you can come back to the Jupyter Notebook. That's exactly the same link I use. So this may take a few minutes once you run it. I already run this. Now once you run that, you're going to see a directory created for COVID-19. To actually get the full data set, get the path, so we can actually find those files. So the data I want to analyze is the summarized time series. So we want to analyze the confirmed case from the US and the confirmed case from global. And the way to find the full path is click those three dot symbol and then copy the path. So then when you come back to the Jupyter Notebook, and there you will have the full path. So in this case, I already put that full path in the assigned it to the variable full path 1. That's the US data set. And then we use pd.read CSV to read the US data set. And we can ignore some error lines. So, and similarly, we copy the full path for the global case and then read it into a df2. So, and once we have that, we will have the df1 as the US case. So we first can use the df1 shape to check the dimensions of the data set. So right now we have 3,340 rows and 248 columns. And we can use head to look at the first few rows of the data frame. And in this case, we can see that's the first 5 rows, and then we have some meta information. ISO 23 code, FIPS, admin 2, province or state, country origin, latitude, longitude, combined key. There is a typo there for historical reason. I guess they never changed it. And then there are the dates. Each date is a column, and all the way to the most recent date, that's the September 14, which is yesterday. So, and then we can use dot columns to see the actual columns. So you can see the date actually are in string. So, and we can use tail command to see the last few rows. One way to index a specific cell or a list of cells is to use the double bracket way. So in this case, we call df1 admin 2. Admin 2 is this column, and then we select the rows. In this case, we select the row 3335 to 3339. So there, that will be taken. And those are the values there. So, and you can also see Python is Pandas is end exclusive, so 3339 actually is not there. if you want to include 3339, you actually need to put one more index there, and then you will see the last one, Western, is there. So, and Pandas also offer another command called iloc. In the iloc, you have to use the integer to specify the location. And in this case, the first component before the comma is actually the rows. So 3335 to 3340, those will be rows, and then those will the part after the comma is the columns. So in this case, admin 2 is what? 0, 1, 2, 3, 4, 5. But because Python is ending exclusive, so we're going to put the 6, and then we're going to 4 and 6. Yeah, so then we see the Western FIPS. I'm not sure what this means. Western is there. So if you want to see the state, we can put the 6th row. So they are all from Wyoming. And so Pandas actually offer a lot of built-in functions. One function is called unique. We can find out the unique province or state in this data set. In this case, we can actually call the province state column by using the dot method. And then we can change with the unique function. So if we want to find out the length, that will the size of this list, and there are 58 province or state. Well, you can see Diamond Princess is also put there as the state. So if we want to find out what's the largest case value in this data set, and now the case actually start with call 11s. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th. That's the 11th column. So 11th column and to the end, and the rows is every row. So that's comma, and this is iloc syntax. So the rows is every row, and all the cases column after 11th column. And then I found out the maximum value, but this actually calculates the maximum value for every column. So if I found out the maximum value of this result, I can call the maximum value again. There, that's the highest cases in the USA today, or yesterday actually. And if we just call a specific column, let's say September 14th, that's the same thing, and the largest value. A day before will be a smaller value, a few, look like a few thousand or a few hundred, 700 less. Now, let's check that to 14. But which row have the largest value? So in this case, we can just that's done the September 14th, and we found out the df1 that's a data frame, that column September 14, 20, that's the column, and then equal to oh, I need to change that value. That's 254656, and then that's the position, and then we put it back into the loc. LOC probably stands for location. That's location for rows. So we run that. That's actually the 213 row, and that's Los Angeles, California. And we can scroll all the way to the right and see, yes, September 14. And the first case is reported on January 26. Okay. So there are different ways to index this. Now we know that position is 213. we can use ilog to index those. So df.ilog 213, and then the value is from 11th to the last one, and let's call that LA. So once we index that, we can see the type. The type of this data is actually Pandas series. So we actually can, Pandas actually provide a plotting function. So we actually can plot that series directly. So there. From January 20 something to September 14, it's actually increasing. It slowed down a little bit in the end, but it's increasing quite dramatically. So now you can also see Pandas now do the plot, but it's plotting by columns. But the Johns Hopkins data set put a time series by rows. So we have to transpose the data frame and then do the plotting. So in this case, let's say for the sake of demonstration, let's pick the first few rows from the original data frame, and then we pick all those cases, which is 11th column to the last, and then we do transpose. Let's call that US cases, and then we can check its shape. And in this case, well, there are 239 rows and 3 columns. If we print that out, you can see, well, it's called the first column, second column, zeroth column, first column, second column. Well, that's because Python started the first with 0. And then we have the actually date as the row number. Notice that's actually not the actual date, it's actually a string, but it's for the time being it's okay. So, and then if we can now actually plot those out. So, and Pandas actually allow another parameter. We can choose subplot which is false, or subplot which is true. False is actually by default. So if I don't put anything there, it's also subplot is false. So there. So, and then the blue is the first column, yellow, orange is the index with 1, which is second column, and green is third column. And if we specify subplot is true, and then we can actually have a sub panels. Each plot has its own panel. So there, 0, 1, 2. And we can also try a few more, and then of course if we pick the say ilog is first 20 rows, then we can do the same plot, and then obviously this becomes more confusing. Now this is nice, but it will be more meaningful for us to know what those rows are. Where are they? This number is not very meaningful, so we can try to add some meaningful index to the data frame, because that's by default is the column name. So we can just reassign the column names, and then we will have more meaningful plot. Now, one way to do that is just when we load the data frame, the data, we can specify the name index with the name, a meaningful name. In this case, the column 10, which is a combined key, is actually a meaningful value, because when we go back to the combined key, you see that's actually a city, a state, and then a country. So that actually is a meaningful key. So when we wrote, one method is just to read that with a new index, and then if we not this time, if we look at index, it actually has the location of the index. But when we do this, you can see that column now is missing. In fact, you can check it. Now the combined key is missing because the read as a row name now. Now another way is just to reassign it. So let's say we still read the full file without specified index, but we can actually use that column and give it a new row index and just assign it back to the index. And in this case, we also will still keep the not combined key as the other column in the data. So we didn't actually change the shape of the data, but the row name is now renamed with the location. So in this case, we can also double check that's the case. In this case, now we can loop over the entire data set and then let's say do a group of 10. For every 10 rows, we do a plot. But obviously that's still a lot, so I only do first 100. And we take, using ilog, take the ith row to the I plus step, which is 10. And then we transpose, do the plot. That should be okay, yeah. And then we assign the US cases, yeah. After transpose, we assign the UK, and then we do a plot, yeah. So, yeah. So now we have the first 100 rows plotting the 10 small figures. So Alabama, Alaska. So that's that's public counties, by the way. This is okay, but notice there are some unassigned cases in the data set. So if we find out how many, for example, in this case, there is an unassigned case at Wyoming. If we plot it out, you can see in the early September, there's a lot of unassigned cases, and then it becomes clear out. We can actually use a string.content to find out all those unassigned cases here. And in this case, we see there are 52 rows. We actually can print some of it to see. Now, if you look at Alabama, Alaska, Arizona, many states have unassigned cases, but hopefully they all resolve after some time. So, and we can also use group by. That's the keyword. Group by what? Province and state, and that way we don't have to look at so many counties. So we can go over all the cases from after the 11th column, and then group by what? By the values in the province and the state, and those are the state value. And we assign it to the group by state. And for every state, how do we group them? We group them by sum, which is total. And in this case, what we have is, let's say, well, for Arizona, it's going to have 1 for Alabama. All of them going to sum up. American sum, that's all 0. Apparently, wow. That's impressive. They have 0 cases. Okay. And then in this case, if we plot all the states, wow. So that's actually still a bit confusing because there are 50 some states. So, but we can actually pick a few states to plot. So using ilog. If we pick the, say, first the 6, well, maybe, so let's see. So I first transpose them and then pick using ilog to pick the first 6. Actually, the NX is the first 5. And that's how it looked like. this is American summer is a 0. That's quite impressive. But it's actually more meaningful if we just using the states directly indexing them. So in this case, we kind of pick the location by the Tennessee, say, and then do the plot. So yeah, Tennessee cases, well, it's increasing quite a bit. So it's become almost linear at the end. And this is okay, but how can we get the daily new cases, right? So this seems to be increasing, but how do we get the daily cases? It turns out we can use the differ function on the. So the differ function in Python, Pandas, actually offer a parameter axis. If axis is 0, it's differ by rows. If axis is 1, it's differ by columns. And in this case, we are going to do the differ by 1. So, and then if we, after, let's look at the first few rows. In this case, wow, they are all 0, 0, 0. And then now you see it's not you see the daily cases. And now we can actually plot those daily. We call this new data frame what? Data frame daily case by state. And so those index are state names. Because we are plotting them by column, so we first do a transpose, and then we are selecting those columns. In this case, we select Tennessee and Wisconsin, do a plot. So in this case, the blue is Tennessee, the orange is Wisconsin. And this is a bit noisy. Apparently, Pandas also offer a function called rolling window. In this case, I apply the rolling with a window size of 3, and then I apply the mean function, and then do the plot. In this case, I also choose a log y is true, which is a log plot. Otherwise, it's hard to see the Tennessee and Alaska, because Alaska has much fewer cases. So if the log plot is false, and then you see that Alaska is almost become flat compared to Tennessee. But if we change it to a log, we can see both data quite clearly. And another way, if we don't want to do this, we may just do a subplot is true. And this way we'll have Tennessee and Alaska in its own subsection of the figure. But then you need to pay attention to the y-axis are not the same anymore, so they are not on the same scale. Now those are also okay, but remember we are now looking at the entire data set. What if I only want to look at a few time window, let's say September. And let's look at the first few rows. So, but we want to change the index into a time series. So the way to do that, use pd.toDateTime with the previous index, and then reassign it to an index. So after we do that, now we see now the index is actually the time, date time index. So now we actually can subsetting a few time window. So in this case, I look at the, let's say, if we look only the September 09, 01 until yesterday, which is 2020 September 14. And in this case, I'm looking at Alabama, Tennessee, Georgia, Virginia, and Florida, and then do a subplotting. Okay, thanks. I hope you find it useful. Bye.